how do we approach this problem? Well, we've been learning about peeling off to make a good du. I do see a cosine cubed. So let's just rewrite it. So many times when we rewrite it, we can recognize things. So let's carry this along. And I'll put this cosine of theta d theta, right? Because cosine cubed is cosine squared and a cosine. Hey, wait a minute. Couldn't that make a good du? And if du is cosine, doesn't that mean u is sine? Oh, look at that. U is sine. That would take care of this. How am I going to deal with this guy? You know that's 1 minus sine squared. So take the time to rewrite it in terms using, the identity, right? Sine squared theta plus cosine squared theta equals 1. And then I'll carry along the root sine of theta and then the cosine of theta d theta. Now use the substitution. So this is du, this is root u, and this gives me 1 minus u squared. Now be really careful in multiplying out. So when I multiply 1 times this, that just gives me, I'm going to write it as the exponent that it is, because that's how we have to deal with it, right? Add 1 to the exponent to integrate it. So minus, so u squared times, I'm just going to write it down here, u squared times u to the 1/2. You add the exponents, right? So that's u to the 4/2, u to the 1/2. So that gives me u to the 5/2 because I add the exponents. Now I'm ready to take the antiderivative. So this gives me u to the 3/2 times 2/3 minus u to the 7/2 times 2/7 plus a c. And then I would put the u back in. And what was the u in this case? The u was sine. So I would say this all equals 2/3 sine of x. I'm just going to put parentheses here. Minus 2/7 sine of x to the 7/2 plus a c. So it all started with thinking about peeling off to make a good du. So this one here, and the next two actually, I'm giving you hints. I want you to think about taking and separating it around the addition or subtraction in the numerator and then thinking of them as two separate integrals. All right, let's think about this. Okay, so let's write this as x over x squared plus 16. And I'm going to put dx plus -1 over an x squared plus 16. Okay, so this one here, this negative, I could have pulled it out front, right? And made it -1 over x squared plus 16. Nothing different, right? And then I'll just carry this guy along. So just making sure you know that you can rewrite it differently. So this one here, I would do a u substitution. Let u equal the denominator. And the derivative gives me 1/2 du x dx. Oh, will you look at that? X dx is the numerator. Oops. So then I would have 1/2 du over a u. Okay, so that's this problem. And so let me go over to this one. Hey, you recognize this. Isn't that arctangent? So this gives me a minus a 1/4 arctangent of x over a 4. This here gives me an ln, right? So I'd have 1/2 and then ln of the u, and I'm just going to take liberties here and put in the u, x squared plus 16 minus a 1/4 arctangent of x over 4 plus c. Okay, that was kind of challenging. So now let's go to the next one. Same idea. Split it around the addition, subtraction. This one has addition in the numerator, and I want to make sure that you have memorized all of the arctangent, arcsine things. So this is going to be x over root 9 minus x squared plus 3 over 9 minus x squared. This needs u substitution because it's got the x up there, right? So du would be negative 2x dx. So I get a negative 1/2. And then if I rewrite this as u to the negative 1/2, right? This is exactly arcsine. So I carry the 3 along, right? That 3 carries along. And then the antiderivative of this would just be arcsine of x over 3. So then taking the antiderivative here, so I get a negative 1/2. And add 1 to the exponent, you get a positive 2, u to the positive 1/2. And then, plus this, right? Plus this 3 inverse sine of x over 3 plus c. So these 2's will cancel. And so then what I end up getting is just a negative root of the u, so negative root of the 9 minus x squared, and then plus the 3 inverse sine of x over 3 plus c.